Okay, so I'm no longer in auto. I have to go straight to warm because that's the only one we can power down. Okay, so I've chosen to manually go warm. So now I'm in this position. Now, DC right here, DC right here, coming down, comes through 2, which is DC, comes down to the power of the coil, and the relay, comes through 5, DC, and comes down here. This whole path is DC, okay? Yeah.
So the only time it would be AC if something converts to DC. I mean, sorry, the only time it turns to AC is something converts it to easier.
Inverters go from DC to AC. What goes from AC to DC? Rectifiers. Okay, we have transformer rectifiers, they step up, step down, but no matter what, always remember, converter goes from DC to AC, rectifiers go from AC to DC. Okay, so we now know how this works. It works with this DC circuit, right?
Right.
But for operational standpoint, you see one selector makes all these happen. I need to go to warning. This is DC, this goes nowhere, does it? Comes through, dead, nothing. It doesn't go anywhere besides I acknowledge the power to this here to close, open, whatever. This is the one I wanna watch for, because what does the relay do? In a normal position where this does not make it to ground, it's open, it's power standing by right here at B, right?
Right.
It's standing by right here.
That's what Bud said, yeah.
Yes. Standing by, but it's not doing anything until it makes ground, then it will complete its path, right?
Right.
So, it does, let's say they contact, that means automatically this gets energized, it then comes down to C. That means that, coming in, let me come down here, this is AC and it comes in. What happens then is right here at 3, DC coming in, 4 is AC. So when this thing gets energized and brings it down, it's then gonna come from 3. What did I have this? That's it.
Like this. A little confused.
This is supposed to be like this. 33. We have vent, we have off, we have auto, we have warm, we have cold, and then we have vent, off, auto, warm, vent, vent, off, auto, warm. Now I'm laid out correctly. This is warm, this is warm, this is warm. Just make sure, you know, like I just did, I got on my wrong port. So, how does 3 get power? 3 is AC, 3 will then come through here as, at B, it's gonna be AC, that means coming through 4, we're AC. Okay, or even C, we're AC. So, this gets triggered, brings down DC, which is here, AC comes to the top there of the relay, so then it pulls it down, so now 1 is what I wanna look at. So I come through here, it comes power, that's just a tie point, then comes down and manually cold.
Wow.
So, the whole purpose of the component of overtemp was to protect the system in an overtemp condition. The only reason why you're in overtemp is because you're in warm, selected for the comfort of the aircraft. Well, because we exceeded the value, the overtemp circuit gets triggered, triggers the overtemp relay, then reroutes the electricity to bring into the control box. Now, the control box is your computer. It's the brain box of it all. It takes inputs from your selector. It takes inputs where it exports the signal to the valves. It also brings in inputs from a cabin selector, a duct sensor, or a cabin temp. The cabin temp selector only works in the auto position. Everything else is whatever you have manually chosen. Right? Okay, so that's how H then you would be getting power. Now, for troubleshooting wise, you're gonna find in that circuit that there's a problem, but it gets activated to cold. Let's see who finds it. You know how you draw it out. It's been drawn out. Do I care about this circuit? No, so you eliminate that. Do I care about this? Yes, because the only way that it's going to code is because of this. Now you're gonna find, I haven't put the infrared gun out there to maybe help you a little bit, but you'll find that it does change a little. You are not to be in front of my air cycle machine and think you're gonna be cooled down and warmed up, okay? It only has a very small ventilation motor back there, just enough that you will be able to see temperature changes on my duct temperatures. There's gonna be sensors and you'll see it go up and you'll see it go down, but you're only gonna be seeing about 10 degrees. It's not gonna be dramatic. So normally you'll be able to see what it's supposed to do, and then when there's an abnormal that you put in, it will do exactly what the discrepancy has led you to believe. Now, find where the problem's at. Okay, I got you started on it. How do you feel? If you could do this training, because now you're mixing DC, AC, and you can see it's kind of like a nice challenging diagram for electrical, right? And you breeze through those 4 faults I have, man, that's the hardest trainer you will ever get in this program. There's harder stuff, but boy, you got it, you understand? Just remember that once I leave these poles, I've identified AC, switch your freaking meter. And if you have to manually select your range, select your range. Okay? Now, I'm always gonna do power before going continuity. So, if I need to check this cannon plug, make sure you turn your inverter off. You don't have to turn off the rest of the system, but you better turn off the power source that comes with this cannon plug. Do not remove cannon plugs with a power source. You're dealing with my equipment that is probably 60 years old. It's kind of hard to damage it. So I, a couple weeks ago, I did something stupid.
Yeah.
But I'm old. See, I was smart for a very long time, and I got stupid again.
Steroid.
I